Welcome, everybody. Welcome to our talk entitled Top Build Performance Issues in Android 2023 edition. And with that, I'll hand it over to Inaki.
Yeah, so I'm Inaki Villar, a solutions engineer for Gradle Enterprise. I work previously with as Android engineer, so my customers are usually big Android projects. I've been working usually in large projects. Last companies were Tinder, Agoda in Thailand, and Ryanair. And yep, so additionally, I'm GDE in Android and Kotlin, but mostly focus on build performance of Android builds.
And I'm Nelson Osacky. I'm lead solutions engineer at Gradle. And I also worked previously as an Android engineer, which is why we're here at DroidCon. And also worked at a bunch of large projects like SoundCloud, Square, and also worked at some startups. And I also maintain a couple of Gradle plugins. One of them is Fladle, which lets you easily scale your instrumentation test on Firebase. And I also maintain another Gradle plugin called Gradle Doctor, which gives you actionable insights to your build. I'm not here to talk about those, but I just wanted to mention that. So yeah, as solutions engineers at Gradle, we help customers and prospects. And so we see a lot of Gradle builds. Android builds, Gradle builds, Maven builds, now even SBT and Maven builds. From 10-person app teams to 1,000+ team apps. So what we do is we optimize builds around the world. So that's, I think, one of the coolest perks of the job. Before I was optimizing the build at SoundCloud or optimizing the build at Square. But now what we get to do is optimize everybody's builds, which is quite fun. Increase their build stability and also talk about developer productivity. We also, when we see issues with customers, we help improve those builds or plugins in the Gradle ecosystem. And we usually file bugs or actually make changes to Gradle plugins that are open source that are affecting our customers. And we'll talk about some of those things today. And we also meet with Google and JetBrains to help prioritize issues that are affecting or impacting our customers. And we'll also talk a little bit about an example of that today. So as an Android developer, one can say that you have feature development as something you can work on and tech debt as something you can work on. Of course, there's many other aspects to the job. I'm oversimplifying things, but what I'm here to argue is that tech debt, which can be something like refactoring or improving builds, but slow builds are tech debt, and it always pays off to work on it. Why is that? Well, let's say you have waste in your build. You have 60 seconds of waste in your build, and you build 50 builds per day, and you have 50 developers on your team. That is equivalent to 42 hours lost per day. And if you think of, and that doesn't include focus, right? When you waste time in a build, and you have to context switch, this and that. And 40 hours is basically a full work week, right? So, and that's per day that you're losing. So fast builds matter. And if you're losing 40 a work week per day, that you could basically hire 5 new people without paying them, no recruiting costs, that. Yeah, at the bottom, there's a link for our ROI calculator that helps you understand the return on investment that you would get when you improve your build. So check it out. It's kind of fun to play with. And so yeah, back to this. And it's also very easy to justify working on builds. So when you're refactoring your code, you sometimes have to make a case for why you have to do it. When you improve build speeds, you can measure it very easily. And you can make a calculation of how much time you're saving your team. So yeah, we work at Gradle. We work on the Gradle Enterprise side. You can request a trial. That's the link for it. How many people here have used build scans? The free build scan service, scans.gradle.com. All right, maybe like a quarter of people. Cool. And how many people here are Gradle Enterprise customers? Maybe like 10 people. Okay, cool. we're here to talk about free build scan things. We're also going to talk a little bit about some Gradle Enterprise features, so that's good to know. I also wanted to point out we have partnerships with a few open source projects such as JetBrains, Android X, Apollo, some other ones. You can check them out all there. They have Gradle Enterprise instances that you can check out. But yeah, let's dive into the fun stuff. So let's talk about build caching. If you've ever attended a talk by me before, you've heard me talk about build caching always at the beginning of the talk. Good to get everyone on the same page. So build caching. Let's say you have a Java compile task, which is a very typical task in any Gradle build. You have a set of inputs, which can be source files, compiler args, dependencies. Of course, there's many other parts that are inputs to that task. And then you also have a set of outputs, which in the Java compile case is class files. Any task in a Gradle build can be made cacheable. And what that means is that all the inputs form a part of a cache key that is a unique identifier for the unique set of inputs that are inputs to that build. And when you look up that cache key, you look it up inside the build cache. And if that cache key matches an entry in the build cache, you get the class files. And I realized I was supposed to hand off the microphone to you.
You're doing great.
Okay, you're
keep going. That was great. So, well, and yeah, so that's how Gradle internally is going to identify if we can reuse the output of a task with a cache key. And the cache key is the combination of the different hashes of the different inputs of the task. And just as simple as that. If the hash is the same, I can reuse the class output. So what is a cache miss? So obviously is when we are not hitting the cache, right? But well, more precisely is when we expect a cache hit, but the cache key is different. And why is that? Because the task outcome is the same. So imagine that I'm compiling a Kotlin class. So the task outcome is the same, but I'm not hitting the cache. That's what we understand as a cache miss. And well, obviously, so only inputs that affects outcomes should be tracked as cache. And a cache miss in terms of Gradle Enterprise, you can see that it's highlighted here. We can see that the build cache result was missing, and then storing locally. So to understand better cache miss, we can compare two different build scans. And like here, we are selecting two build scans, and we are going to compare with Gradle Enterprise the differences in the task. Let's put it again. Pick two build scans and that. So once I'm comparing the build scans, I'm going to see that they have a difference in one of the inputs. In this case, is sources, and I have that the file app Kotlin has different contents. And that's the idea. That's very simple, but it's very effective to understand how we can optimize a build, understanding the problems that we have with the inputs of the task. For that, we are offering the build validation scripts, so it's a tool to execute in different scenarios the validation of the cache in your projects. So we have clean builds. What else, Nelson, in terms of the validation?
Yeah, it's a series of experiments you can run on your builds to understand why cache misses are happening, and to also help you it saves all the outputs of all the builds, which makes it really easy to analyze the miss.
Yeah, in terms of the scenarios, we are covering local builds, right? So same location, different location, and CI and local builds. That's something that's quite interesting because you want to compare what you are populating from the CI, you are retrieving from local builds, and that's something very important. Okay, so we are going to cover the common cache misses now, and we are going to start with one easy, that is build configuration differences. So the idea is that in this task, or in this build scan comparison, for the task Kotlin compile, we are seeing that we have a value property that is different, the incremental compilation that's enabled. So this problem is quite simple, right, to spot. So we have in CI a Kotlin incremental value false, and in local, we have true. So one of the important things here is the incremental has no effect in the outcome of the task. But this small configuration could affect your Kotlin compiler hit of the cache. And that's something that I want that you can stop one moment thinking in a local build. So imagine that you have 1,000 modules, and you have this problem. All the Kotlin compiler tasks are going to be executed the first time when you are pulling from the Git branch. So that's a very small thing, but that's something important to think. Okay, next one is about live literals. So DroidCon, we are discussing about Compose. We are very happy. We love Compose, of course. And one of the features is live edit. Well, you know better than me, but it's one feature that allows quick development cycles, right? And one of the problems that we saw using this feature is that with the Java compiler, we are going to see a difference in the live literals. So, well, Nelson, you have a little bit more context about these live literals. What was the problem?
I think it had a fully qualified.
Exactly. So the problem was like we were the task was containing a fully qualified path. That means that when you are building from different locations, you are going to have a cache miss. So the fix is quite easy. So we need to disable live literals on the Compose configuration. But the problem is that some teams are using this feature and they don't want to disable these live literals. So we created, well, there is an issue, and we tested, and it was existing under Gradle plugin 8.1, but we didn't see reproduce it in 8.2 alpha 15. So 8.2 alpha beta 1 is working. So keep an eye on that. Okay, the next one is about KSP. Okay, so everybody's excited, I guess. 2 weeks ago, we got very good news from Dagger Hilt that they were starting to work with Hilt. So that's something that, well, it's going to be a game changer, I guess. And this specific issue that we were seeing, we were testing the Android, the room database, and we were seeing this difference. So that's something that it was a little bit strange, because the room database, we know that we have some problems with this library, but we provide a workaround in our plugins. And still, we were seeing this problem with KSP, with the latest version. I think it was since 1.8, I remember. So, but the problem is like, this build scan comparison is not giving us too much detail about this difference, right? So it's saying that, well, something in plugin options, $0, as task input arguments is different. What's that? So we need to debug the task inputs. And this technique is not only applied for this specific case of KSP. You can apply this technique for all the different task investigations. So the idea is that we need to configure the task specifically, the KSP, and we need to go through the different properties, objects, or different elements of the class. And what we want is to include a custom value in a build scan with the values of the input. In this way, so we are going to publish one build scan with one value and the other build scan with another value. And the result, when we compare two build scans, is that we have for this specific task, for the annotation processor options, we have a different path, an absolute path that was considered when we were building KSP from different locations. But this is very strange, right? Because again, we fixed this problem with the with our plugin, with Android Catch Fix plugin. So, and even more, Gradle, or Gradle Google, added a proper configuration in the official docs saying how to configure a project with Room, respecting the path sensitivity of the path. So we didn't understand what's going on, right? So, and at the end of the day, we went a little bit deeper, and we saw that Google was doing the work well because they were defining an argument provider, and there was something that we were missing. So we pick again the code, the command line argument provider, and we move to the KSP code. So in the KSP, when we are informing about the command line argument providers, we are informing the annotation processor options as sub-plugin option. And at this point, KSP doesn't know anything about the path sensitivity of Room. So it was a problem, and it was causing cache misses for all the different plugins, in that case Room, that was offering this problem. So the solution was finally to change the sub-plugin option to an internal option. We provided the PR, it's merged, and we don't have any glory because this was merged before Dagger Hill announcement, so enjoy your KSP hits with Dagger, but that's something that we fix thanks to the extreme collaboration with Google and the KSP team and us, right? And finally, from my side, I want to mention about Room. So we talked before, right? This is going to be our last time that we are going to talk about Room. So Room was always a very famous topic in our talks of Gradle. To give you more context, Room has like different problems since the beginning, right? In terms of overlapping input-output, in terms of not properly doing the cacheability of the task. And we work very close with Google and with the team specifically responsible for that, trying to address these problems. So we created a specific workaround in our plugin called Android Catch Fix Gradle plugin. If you don't know, it's a plugin that we are providing to fix some of the Android Gradle plugin issues on top of that. So we provided that as well. We were adding not only for KAPT, we're adding compatibility for KSP, but we are more than happy to see that Google has released a new Room Gradle plugin that actually is in beta and addresses and fixes all the previous problems that Room has with Gradle. So if you're going to use Room, know that now it's free of issues with cache. And the behavior is quite simple. So it's like before, you just need to declare the scheme directory, and that's it. So, and publicly we want to thank Google because there was something that we were behind, and actually we created some workarounds for that. So with that, I'm going to pass to Nelson.
Thanks, Inaki. So I'm going to continue on the exciting topic of cache misses and talk about java.net.url and hash code. So this was another interesting cache miss we investigated with the customer. All those were also cache misses we investigated with customers. And this was with the Apollo team. How many people here use Apollo in their apps? Okay, we got a couple of people. So we worked closely with Martin and the rest of the Apollo team to fix the cache issues in the Apollo build itself. And there's actually a Gradle Enterprise instance they have that's public on the web, which I'll show in a sec. But my point is that we started to see this cache miss issue that was happening in the Doka 2 task, this URL. And Martin spent a lot of time debugging it. And the conclusion was calling url.hashcode or not calling url.hashcode changes the serialized value of the URL class. This is very surprising behavior. So Martin, of course, filed a bug with Gradle that the serialization depends on whether or not you have called the hashcode function. And obviously that's an issue for caching because if you call hashcode, you have one serialized outcome. And if you don't call hashcode, you have a different one. It turns out this is actually a bug in the JDK. It was marked as won't fix, unfortunately. It was filed in 2015, so we can't do anything about it. But what you can do is change URL to URI, which is another class in Java. And so that's what Martin did. He made a PR for Doka 2 and just changed from URL to URI, and the URI class doesn't have that problem. Great. So yeah, the Apollo team made a whole blog post about all the caching issues we found in their build. You can just Google that article. You can also check out their Gradle Enterprise instance at ge.apollographql.com. And yeah, we all, like I mentioned before on a different slide, we have a bunch of open source projects. The Android X team also has a bunch. And Orimas from the Android X team has also written an article on all the fun stuff that they found in the Android X build with Gradle Enterprise. Okay, how many of you want to hear about another build cache miss? No? Okay, oh, we got some takers. I thought you guys would all be tired of talking about build cache misses by now. But I'm not going to talk about a build cache miss. I'm going to talk about a configuration cache miss. An exciting new topic now that the configuration cache is a thing. So how many of you have seen this line in your build output? Calculating task graph as configuration cache cannot be reused because, and then there's a reason. So recently, this was happening because com.android.internal.library has changed. So how do you debug this? Well, we don't have a task input comparison for configuration cache yet. So you check the configuration cache report, and it's all green. Everything's great. There's no issues, right? And that makes sense because there actually was no issue storing to the configuration cache. It's just an issue, it's a cache miss. So how do you debug this? You ready? You attach a debugger to the Gradle build process, which you can do by adding the system property org.gradle.debug equals true. You set a breakpoint in the configuration cache fingerprint writer, as well as the configuration cache fingerprint checker. And then you print which files are changing. And we found that build generated source cap debug was being read. Whoops, sorry. Okay, whatever. There's a directory that was being read at configuration time, and it had to do with capped. So looking into that, so there's a couple of things. I'll get into why it's capped, but the question is, why did this start happening in Gradle 8.1? So if you read the release notes, how many people read the Gradle release notes? They're super exciting. I love reading release notes. So there were improvements to the configuration inputs detection. And what this means is it's basically stricter. There are more things that were previously not being checked that were actually inputs to the configuration cache. And just so you know, Gradle 8.1 was when the configuration cache was marked as stable. So it now detected file collections being queried at configuration time. And it's in the release notes, so you can check that. But the ecosystem of Gradle plugins hadn't really caught up to that yet. So we filed a bug with capped. We're like, hey, you're reading these files at configuration time, because we work closely, as mentioned before, with the JetBrains team and the Google teams. And they were like, actually, no, it's you, Gradle. No, sorry, it's you, Google, that they're calling the register external apps Java output API, and that's not compatible with the configuration cache. So they filed a bug with Google, and Google fixed it in AGP 8.1.1 and AGP 8.2. So yeah, great case for always being on the latest versions of things. So does anyone want to talk about more configuration cache issues or remote build cache issues? Yes, we got takers. I'm glad you guys are following along. But no, we're going to switch gears a little bit now. And talk about how Gradle Enterprise can help you be proactive about fixing things. So we have the Gradle Enterprise API, which if you have Gradle Enterprise and you have all your builds being recorded by your Gradle Enterprise instance, you can query a bunch of different things. There's the builds API, there's the build cache API, there's the test distribution API. I'm not going to get into all the details of that. The docs are on our website. But I wanted to talk about a new API we're building called the test API. And it's in beta. It's not announced on our website, but I'm sharing it with you all here, which is super exciting. And what does it let you do? It lets you retrieve test suites and test case details, and it lets you filter by test container, which is basically the test suite, the test class. And you can also filter by test outcome, whether a test succeeded, whether it failed, and very excitingly, whether it was flaky or not. And then, of course, you can filter by all the same things you can do in build scans, such as tags, custom values, and all that. But yeah, flaky tests. How many people here have flaky instrumentation tests? All right, everyone who's not raising your hand, I know you also have flaky instrumentation tests, or you don't have instrumentation tests. Yeah, how do you use this API? You can call your Gradle Enterprise server /API/tests/containers. The container, you can give it a wildcard, such as there. And then if you filter for test outcomes equals flaky, you give it a start time and an end time. And that's just some of the parameters you can give it. Of course, you can also filter in many different other ways. And with that, you'll get a very fun output, which has both the test name and the outcome distribution. So here you can see when that test was executed, whether it passed, whether it failed, skipped, flaky. And then you also have the build scan IDs, so that you can go and retrieve those build scans and create links to the build scans that ran that test. And I know talking about APIs is super exciting. So yeah, there's another API which is basically the same thing, which is a test cases API. And here you'll filter by test container. And the outcome of this API is very, very similar, except you don't have a list of containers. Here you just have one test container. So what can you do with this API? Actually, before that, let's talk about what is a flaky test. Of course, you've all experienced this. According to Gradle Enterprise, flaky test is a test with a non-deterministic outcome, and that means it fails and succeeds within the execution of a single Gradle task. So there's many tools out there that allow you to track flakiness and things like that. Some of them do it by just checking how many of this times this test failed on master. We don't think that's an accurate way of counting that. The way we do it is we retry the test. It's part of the Gradle Enterprise plugin. And if the test fails with exactly the same build inputs within the course of a single Gradle task, it will be marked as flaky. And the other thing about flaky tests is they make you bang your head like an emoji on your keyboard like that. So yeah, what can you do with this API? So one idea is you can prevent flaky tests from creeping into your code base by adding comments on PRs when new flaky tests are introduced. This is just an example here. You can also alert on tests that have become flaky in your code base that previously weren't. And you can create Slack bots, connect it with whatever. Another idea is you can cross-reference it with your repository structure, for example, and provide a comprehensive report. This is one of our actual internal reports on flaky tests that we get in the Gradle build. Here you can see build scan aggregation. You can click the links to view those build scans. It knows about the module structure of our build, as well as which teams are responsible for those things. So yeah, here in the bottom, you can directly assign ownership to those builds based on build scan attributes. You can also create a report that looks like this, where you have commits and then the flaky tests that happened on that commit. You can cross-reference it with your CI infrastructure based on the tags that are part of the build scan and define flakiness across infrastructure, test matrices, that sort of thing. You can combine it with other tools such as the shampoo rule, which shampoos away your flaky tests. And add tests to quarantines. You can see where all the fun stuff you can do with this flaky test API. So reach out to us after the talk for access to the test API if you're a Gradle Enterprise customer. And you can also reach out if you're a Gradle Enterprise customer and you aren't already importing your instrumentation test results to Gradle Enterprise. Please also reach out to us about that. And now I'm here to talk about another exciting new Gradle Enterprise feature for Android people, because we love Android. So before I get into this feature, I want to talk about what are artifact transforms. So artifact transforms are a dependency management concept, and basically it changes a dependency from an incorrect format to a requested format via artifact transforms. An example of this would be transforming a jar file into a DEX file. So users or build authors do not directly request transforms, but Gradle automatically schedules transforms between units of work in order to match the requested dependencies. Transforms themselves can depend on other tasks, and they can also depend on other transforms. And what I'm here to tell you today is that artifact transforms are now available in build scans. You must, yeah. All right, yeah, you know how exciting this is. This is really one of the most commonly requested features by the Android community because Android builds, the Android Gradle plugin, use so many artifact transforms compared to other Gradle builds. Believe it or not, non-Android people also use Gradle. So yeah, if you're using Gradle Enterprise 23.1, or Gradle Enterprise plugin 3.13, and Gradle Build Tool 8.1, then you can see your artifact transforms in Gradle Enterprise. And yeah, there's also constantly being improvements made to this feature. So if you're using the Gradle Build Tool 8.3, there's even more artifact transform insights. So yeah, always stay up to date. Did I mention that before in this talk? Always stay up to date? I think I did. So yeah, what does this look like? In build scans, in the top corner, it has a thing that says number of tasks. Now it also says number of transforms. And transforms look like that. They have the artifact type down there. And you can also see how long those things took. And when you click on that in the timeline, you get the details. You see the requested type as well as the target type for that transform. In this case, we're transforming ASM instrumented jars into Android DEX. And you can see how long that transformation took. So yeah, why is this important? This helps you understand transform dependencies, of course. Helps you understand gaps in the timeline view. So in the build scan timeline view, there used to be all these gaps, and people are like, what's going on here? Now you know. It's artifact transforms. And it also helps you understand artifact transform errors, which were very hard to debug before. So yeah, first thing, understanding artifact transform dependencies. So now when you click on an artifact transform, you can see which other transforms or tasks that artifact transform depended on by clicking the predecessors tab. You can also do this for Gradle tasks. It works exactly the same way. And then you can also see these filled gaps in the timeline. So right now I'm filtering the timeline by artifact transforms, and you can see how many transforms were part of this build. And before those were just empty spaces on the timeline. Yeah, and then you can also view artifact transform failures. So for example, if you had a build caching failure in your artifact transform, that would not be visible. And you can also search for transform failures in the dashboard. Yep, and so this is a brand new feature. It's being improved on a bit. So actually, this was just released with Gradle Build Tool 8.3, but if you're using Gradle Build Tool 8.3, you can see the cacheability and up-to-date checks of transforms. You can also, there's an improved transform filter in the timeline. You can filter by cacheability and up-to-date checks. And it's going to support more transform types like Jetafire. Is Jetafire visible in 8.3?
Well, not between projects.
Not between projects, yes. And that marks the end of the talk. So there's some more resources here on our website. So if you want to know more about how to use build scans, if you want to know more about Gradle, we actually have an amazing trainer. His name is Akshay, and he runs trainings very frequently. So if you go to gradle.com/training, we have an Android-specific training, so Gradle for Android build authors. And then we also have a Gradle community Slack. That's the link to the invite there. And then, so yeah, then there's we're hiring for a few positions. There's a link to the training, link to the trial, and you should also definitely come visit our booth. We're hanging out over there. You can ask us questions. You can complain about your Gradle build being slow to us. We love listening to people telling us about that. And yeah, that's it. You want to say anything?
Yeah, well, that we have T-shirts, right? I mean, like this one. So, yep. Thank you very much.